Hi, I'm Brad with the experimental sales team at Garmin, and welcome to our virtual AirVenture Oshkosh experience. Today, we're going to overview some of the equipment that is available for the experimental and light sport aircraft market. You can see on the display here, I have a very well-equipped IFR setup for our home-built and LSA aircraft, whether it's for your own primary use or IFR flight training. Beginning in the middle here, we have the G3X primary flight display that is paired with a G3X multifunction display over on the right side for a second pilot or a passenger. In the middle, we have a GMC 507 Autopilot control panel, GTN 750XI for a Navcom radio, as well as an IFR GPS navigator, as well as a GNC 255 Navcom radio. Backing all of that up, we have the G5 electronic flight instrument that is tied in with the rest of the system, but can act as its own standalone instrument or as a backup to the rest of the flight displays. The G3X Touch system can accept navigation information from a variety of sources. Each primary flight display includes its own VFR WAAS GPS receiver. So the primary flight display can provide all of its own navigation information directly from the screen. We can also accept navigation sources such as this GTN 750 XI IFR GPS navigator, or if you have a portable unit such as an ERA 760 as shown here, we can accept the lateral navigation information from that unit as well. The G3X Touch primary flight display gives the pilot a lot of information and is laid out similar to other glass cockpit flight systems. You can see on the primary flight display, we have synthetic vision for our artificial horizon information. This can be displayed as synthetic vision, a typical blue over brown basic attitude presentation, or 6-pack gauges. On the left side of the primary flight display, you see we have our Airspeed Tape, which gives us basic airspeed information, such as indicated airspeed, ground speed, as well as true airspeed for your aircraft. In the center, we have the highway in the sky boxes you can see there for navigation information, as well as a flight director and command bars for artificial horizon and autopilot functions. Over on the right side of the primary flight display, you can see our altitude information, such as indicated altitude, selected or bugged altitude, as well as a barrel information on the bottom of the altitude tape. Over on the right side of that, we have our vertical speed indication for our climbs and descents to let you know how quickly you are descending or climbing. On the bottom center of the flight display, you can see the HSI, or horizontal situation indicator. This gives us our magnetic compass as well as our lateral navigation information, either from the internal VFR navigation capabilities of the G3X flight display or from an external source such as the GTN IFR navigator. We also have additional data points such as the inlaid Inset Windows. These can be changed based on pilot preference, but these give us some additional information. Currently, it is a map display for our navigation information and a flight plan page as well, so we know which upcoming waypoint we have coming up within the navigation system. On the bottom of the flight display, you can see we have two dual concentric knobs. Based on the function that I am performing with the G3X Touch flight display, those dual concentric knobs will change their function, and we will go over that as part of the video. We also have 4 different soft keys available on the primary flight display, including nearest for our nearest airport information in case you need to get down quickly, a direct to button for our basic VFR navigation functions within the G3X flight display, a menu button to access all the options within the system, as well as a back key to back out of a certain menu or split screen multifunction feature that you're currently on. A very convenient feature as part of the G3X Touch system is the bezel that is built in around the primary flight display, as well as the built-in lip along the bottom of the primary flight display. This provides us resting points for our hand in case we're flying in turbulence if your concern is bouncing around while trying to use the touch display of the system. However, every function we go over today on the primary flight display is accessible by the button and knob commands as well, so you actually don't have to use the touch features of the display if you choose not to. The G3X Touch primary flight display allows us to interact with a variety of remote mount avionics or panel mount avionics. We will begin with the Navcom interface that is enabled currently with the GTN flight display as well as remote mount radios within the system. You can see we have COM1 selected here on the top left of the flight display. This enables me to flip-flop frequencies on my primary COM radio, whether that's a remote mount GTR-20 COM radio or a panel mount radio such as a GTR-200B or maybe this GTN-750XI. By selecting the standby frequency of the COM radio, this will bring up a split screen frequency radio page. Now you can see, as mentioned earlier, the dual concentric knobs of the primary flight display have changed their function. We now have available a volume and push to squelch key, as well as a tune frequency and hold to transfer knob. This allows us to interact with a variety of radios very similar to a dedicated panel mount interface. You can see here, I can either tune a radio frequency using the dual concentric knob like we would traditionally with a panel mount radio. I can also touch to type a radio frequency if I choose to do that. Or I can use a very handy find feature that accesses a variety of databases on the G3X Touch flight display. By selecting the find feature, we can see we have our recently used pilot frequencies, frequencies for nearest airports, frequencies for those airports accessed on my flight plan, as well as pilot and user-defined frequencies. You can see in order to select a frequency from the database loaded on the G3X, let's say I use my nearest airport. You can see my nearest airport is the Columbia Gorge Regional Airport. I can go to select frequency, and maybe I'm looking for the Unicom frequency today. By touching that frequency, it has now sent that to the standby frequency of the COM radio. And it will even enunciate that COM radio frequency shown here. To flip-flop the frequency to my active radio, I simply touch COM1 and it has now loaded that COM frequency into the primary transmitting radio. Similar to the pilot interaction with the COM radio, we also have a choice to interact with a nav radio within the system. Typically the nav radio on the GTN-750XI, or that could also be a GNC-255 nav radio. By selecting the nav radio button there, we now have the same split screen interface that we see with the COM radio. I can use the search feature to find a specific nav frequency. Maybe that's for an ILS approach receiver or a VOR receiver. I can touch to type it or use the dual concentric knob to tune a nav radio very similar to the COM interface. I can select that frequency and it's going to send that to the standby in the nav radio. Here, I can transfer that frequency of the nav radio by selecting the transfer button on the split screen multifunction feature. The pilot can also interact with a variety of transponders available from Garmin. This can include panel mount certified transponders or remote mount transponders if you don't seem to have the panel space. At the top center of the primary flight display, you can see we have a transponder selection key. We also have an ident feature available top and center, available to the pilot at all times. By selecting the transponder key, this is going to bring up the transponder multifunction display page. You can see here we have options for quick reset back to VFR. And we can also go ahead and touch to type a squawk code directly for our transponder. We have our modes available here for standby, on, and ground squawk modes. However, this is airspeed keyed, so when you take off, it's going to automatically begin transmitting your position, so we rarely have to interact with that. We also have the ident feature here on this page as well, but we can go ahead and touch to type a squawk code in, press enter. We now have that selected on the transponder. The pilot has a lot of different choices when interacting with the primary flight display. If you'll notice, some of the data bars and the data pieces on the PFD of the G3X Touch system will be outlined in gray. If they are outlined in gray, that is a touchable feature within the primary flight display. For example, on the altitude tape, if we want to change our bugged altitude, I can either use the dual concentric knob and use that in order to roll an altitude in. Let's say we need to go to 8,000 feet. I can also touch and select that and type in the altitude as well. The same goes for my magnetic heading bug. I can roll that bug around to the specific heading that I desire. This also allows me to push to sync that heading as well to my current heading. I can touch and type as well. The inset windows give the pilot a lot of different information pieces as well. One great item about the inset windows is that they are a shortcut key to the multifunction display page. Let's say I want to have a quick access to my map display here. Or my primary flight display active flight plan over on the right side gives me a quick shortcut to that page as well. The inset windows are pilot selectable. By touching the HSI on the primary flight display, this brings up primary flight display options. You can see my inset windows here. I can change those based on the function I desire. You can see I've now selected a traffic page as well as a G meter for aerobatic flying. That will give me a quick access key to that multifunction display page or a quick reset of the G meter. On the top center of the primary flight display is the AFCS control panel. That's Automatic Flight System Control. By selecting that, it's going to bring up the split screen multifunction page and give me a choice to control my autopilot system within the aircraft, either from the primary flight display, or I can still accomplish that from the dedicated GMC autopilot controller. Standard with the G3X Touch system is a very useful multifunction display option. You can see in the top right of the primary flight display is a split key. By selecting that, it's now going to bring up the multifunction display split screen options. We'll begin with the map display. You can see you have a standard base map display, which gives a very simple navigation interface interaction for the pilot. This is finger touch panning as well as pinch zooming. You can select north up or track up quickly and access a variety of map options from the menu key on the primary flight display. Let's say you want to overlay weather that you're receiving from an ADS-B transponder. I can allow that weather as well as animate it directly over the base map of the G3X Touch multifunction page. Scrolling over one page on the multifunction display feature of the G3X gives us our charts page. This shows us a standard FAA VFR sectional if you choose to navigate based on that. By selecting the menu key, this will also allow us to change between the charts and the databases of G3X Touch. Let's say we're on an IFR flight plan and I choose to have my IFR low charts there. That will now bring up that IFR low en route chart and I can navigate based on that chart as well. By scrolling over one page, this is going to give us our Waypoint Information page. You can see I have the airport in my flight plan shown here, 4 Sierra 2. For that airport, it gives us a lot of different pieces of information, including the elevation, services available, as well as bearing and course to that airport. I can select the frequencies for that airport based on this page and send those to either COM1 or COM2 that is tied in with the system. I can also select the runway information page, including type of surface, width and length of the runway, traffic pattern information, as well as the wind data coming in from the ADS-B or XM information to the screen. That allows us to get the crosswind or headwind components and choose the best runway. There's also a dedicated weather page specifically for that airport that's going to give us a decoded METAR or terminal area forecast if we are receiving that data. Also based on this information from ADS-B-in, we have a NOTAM information page to view any specific pilot NOTAMs available for the airport. Also available is the Airport Facilities Directory page. This gives us all of our airport information from the AOPA facilities directories, as well as contact information such as phone numbers, local restaurants, additional frequencies, and other pieces of data that might be useful for the pilot input. Also available on the airport Waypoint Information page is a charts page. This allows us to access the databases within G3X Touch to give us items such as georeferenced taxi diagrams or IFR approach plates. I can select an appropriate IFR approach plate, bring that up on split screen page for preview, and also expand that to full page on the multifunction display option. This will now allow us to brief the approach and gives me a georeference chart to go ahead and fly an IFR approach when it's so equipped with an external certified IFR navigator. Moving one page over on the multifunction display of the G3X Touch is a dedicated weather page. When we're receiving ADS-B or XM weather data, this page populates with a variety of very useful information for the pilot. That includes next rad radar, cloud top forecasts, winds aloft, temperatures aloft, lightning strikes, as well as additional data pieces such as current TFRs, SIGMETs, AirMets, or other NOTAMs related to our weather. There's also available pilot reports to see if there's any pilot reports for the weather in your area, as well as forecasts for turbulence and icing. Moving one page over on the multifunction display brings up a dedicated terrain page. This is going to show terrain shading around our current flight path. You can see anything within 100 feet of my current flight altitude is shown in red. Anything within 1,000 feet is shown in yellow. We also have a profile view along the bottom of the split screen display page, which is going to show any terrain shading that might be in my current flight path to let me know if I need to increase in altitude. One page over on the multifunction display is a dedicated traffic page. This is really great for the pilot for situational awareness when receiving ADS-B and traffic information to the primary flight display. That will show Garmin's patented target trend technology for our traffic, which gives us relative motion from other targets within the area, or terminal traffic, so I can view ADS-B and traffic information when flying up to a specific airport. If you're equipped with Sirius XM on board, I have an option in order to control the audio and entertainment from that Sirius XM receiver. You can see on this page on the multifunction display, we have our Sirius XM channels, which allows me to handle all of the entertainment options available that will provide that through the intercom system in the aircraft so I can listen to my music while I'm en route. Next over is a basic information page. This allows us to see what type of satellites we're receiving, as well as the current location of the primary flight display while we're in flight. Also, the final page on the multifunction display feature is the dedicated EIS engine page. This is currently configured to show the basic EIS over on the multifunction display in front of the co-pilot, but the pilot can have this key in front of them as well in order to view all of the engine information accessible directly for the pilot. The G3X Touch system also has options for an integrated engine information system, or EIS. In this cockpit, it is set up on the multifunction display screen on the co-pilot side. You can see we have a EIS bar here on the left side. That's also configurable to show on the right side of the display or over on the pilot side. This is going to give us basic information such as manifold pressure, RPM, fuel information, and CHT and EGT information. By selecting the EIS strip, that's going to bring up a full page view of the EIS system. You can see we have additional information such as a bar graph for our CHTs and EGTs, our electrical bus health, as well as our fuel information. This is also available on the split screen page of the primary flight display. The EIS system within G3X Touch can be interfaced with a variety of aircraft engines used today in the experimental and light sport aircraft market. This includes our popular Continental and Lycoming engines, 4-cylinder or 6-cylinder, as well as other light aircraft engines such as the Rotax IS engines or the carbureted ULS engines. There are a variety of custom options available to the pilot if you have an alternative engine install or don't quite have something that is immediately available within the GEA24 EIS system available on G3X Touch today. This includes the ability to custom configure a gauge based on your specific need. It gives us a lot of flexibility to the installer and the pilot to tailor the EIS system to your specific aircraft. One of the greatest features that the G3X Touch system has is its autopilot. On the top center of the primary flight display, you can see the automatic flight control system control panel. This is going to enunciate all of our current autopilot modes that we are currently flying with. And that will bring up a split page mode of the autopilot controls. You can see I have options to select autopilot engage and disengage features, as well as options for the flight director and yaw damper engagement. From this autopilot control page is an option to control ESP. ESP stands for Electronic Stability Protection, and that is standard within the experimental autopilot system available with G3X Touch. ESP gives the pilot a dedicated set of parameters or an envelope that the autopilot will keep the aircraft within. So let's say your hand-flying IFR become disoriented and either exceed a roll that is dedicated within the system or a maximum or minimum airspeed. ESP within the Garmin Autopilot will take over the aircraft and nudge the aircraft back to level and upright. If you still have a problem, there is a dedicated level button available from this control page as well to bring the aircraft to upright and level. You can see in the middle we have our lateral steering information for magnetic heading, track, as well as navigation options to control the autopilot from the internal or external navigation source from the autopilot. On the bottom, we also have our vertical commands. We can climb and descend by indicated airspeed or vertical speed, as well as activate our altitude hold modes from the autopilot. Garmin also has dedicated autopilot control panels, such as the GMC 507 autopilot control head. Over on the GMC 507 autopilot control panel, we have all of the very similar autopilot function commands available as we just accessed from the primary flight display. This includes the autopilot engagement, a dedicated level button in case we have any issues while we're in flight, flight director, and yaw damper controls. What I really like about the GMC 507 control panel is it adds dedicated heading, track, and altitude select knobs. This allows us to bug a specific heading or track, bug a specific altitude, and give our commands for vertical speed and indicated airspeed using the vertical wheel directly available on the autopilot controller. It is organized to be very pilot friendly with our lateral steering commands over on the left side. That includes the heading, track, and the nav buttons, as well as approach activation for capturing a glide slope from the autopilot. And over on the right side, we have our vertical commands, such as altitude hold, climbs or descents by vertical speed or indicated airspeed, or options to navigate by VNav. That's vertical navigation available from either an external GTN-XI IFR navigator or the internal VNav capabilities of G3X Touch. In order to fly some certain commands from the autopilot system, we'll go ahead and take a look on both the G3X primary flight display and use the GMC 507 dedicated autopilot controller. I can engage heading mode and sync to my current heading and steer to a specific bugged heading based on that. That is available from both the GMC 507 autopilot controller as well as a heading bug using the dual concentric knob available on the G3X Touch system. Let's say I want to go ahead and command a different altitude within the system. By using my altitude select knob, I'm going to go ahead and bug 7,000 feet. We're currently at 5,900 feet. Once I've bugged an altitude, I now need to tell the autopilot how do I want to get there. Let's say I want to climb by indicated airspeed. I will go ahead and select indicated airspeed and use the vertical wheel to dial in 140 knots. You can see the autopilot system of the aircraft is going to go ahead and climb based on that indicated airspeed that I have just commanded until we have reached our target altitude. The G5 electronic flight instrument is a great backup option for a flight display to the rest of the G3X Touch system. The G5 is a fully self-contained instrument with its own attitude and air data sensors contained within the unit. When paired with the G3X Touch system, it's communicating on the flight network with the rest of the flight displays, and it will show the same information such as our airspeed, altitude, artificial horizon, as well as the barosync across the rest of the system. If there is a failure within the GSU flight computer for G3X Touch, it will now begin to send its own flight data information as a backup number 2 source to the rest of the flight displays. However, if there is a power failure within the aircraft and I lose my primary flight display, the G5 has an optional 4-hour backup battery that attaches to the back of the unit and will stay bright in order for me to get to the ground or to my next destination. The G5 also provides a backup autopilot control as well. If I lose power to a G3X primary flight display and I still have operation and function to the GTN IFR navigator as well as my autopilot system, I can still shoot an IFR coupled approach based on the data directly from the G5 to the rest of the autopilot system. This gives us a lot of choices for redundancy and safety within the entire avionics system. We spend a lot of time interacting with our avionics system as pilots, but if you're a home builder or an experimental avionics installer, you're also interested in what's happening on the back side of the panel. Here we will go over a quick overview of all the boxes and system pieces that make up the flight instruments on the primary flight display. That will begin with the G3X Touch LRU kit. LRU stands for Line Replaceable Unit, and that just refers to one of the units in the background that can be replaced within the data stream of the G3X Touch system. The G3X Touch LRU kit includes a GSU 25 Adahars flight computer. This is our air data computer that holds all of our solid state accelerometers and attitude sensors, as well as gives you options for pitot, static, and angle of attack inputs to bring all of that airspeed data in from the aircraft airframe. The LRU kit also includes a GTP-59 outside air temperature probe. This is going to give us temperature corrections for data pieces such as density, altitude, and true airspeed. It also includes a GMU magnetometer. The GMU magnetometer is the magnetic heading interface that gives us the magnetic heading data within the aircraft avionics system. You also notice on the backside of the G5 electronic flight instrument, it has its own dedicated pitot and static inputs for airframe information. Moving down the line within the rest of the avionics system installation includes the EIS interface. That is the GEA24. This brings in all of the data from the sensors from your fuel gauges and firewall forward sensors and packages those into a digital display information that the G3X Touch can display those to the pilot. You can see this gives us very flexible mounting options. The GEAs or the GSUs can be shelf mounted. They can also be tied to the back of the instruments. Really depends on your specific aircraft install and how flexible you need to be with your avionics installation. Looking back here, we have the GDL52R. This is the Cirrus XM and ADS-B-N receiver available for the G3X Touch system. So all of our ADS-B-N, if your transponder is not currently capable of that, or the XM data is available to be received through this box and displayed on the primary flight display. Shown here is also the GAD29. This is an AirInc interface. If you're installing a GTN IFR navigator or one of the affordable 2-inch series of IFR navigators, you will need an AirInc interface such as the GAD29 installed on your aircraft in order to read and receive all of that specific IFR navigation information and display that on the G3X Touch flight display. Also available are additional antennas for the G3X Touch flight display system. The GA26C is an internally cockpit-mounted GPS antenna for use for the GPS receiver built into the back of the G3X Touch flight display. We also have available GA26 Sirius XM antennas that's going to bring all of that satellite data information from Sirius XM for display on the primary flight display, such as our weather and audio entertainment. Over here we have the GSA-28 Autopilot Servos. These are very compact, brushless DC servos that control all of our flight control surfaces of the aircraft and enable the autopilot system within the G3X Touch flight displays. All of the autopilot functions for the aircraft are included from the GSU-25 flight computer and the GSA-28 Autopilot Servos, and this gives us that full functioning Garmin autopilot system. Moving here to the back is the GAD-27. This is an electronic control interface, and it is optional depending on what type of aircraft install you have. This is typically for more electronically advanced aircraft with electronic functions such as electronic trim, electronic flaps, multiple lighting buses, and relay systems. That is going to simplify our electronic system wiring for some of those extra auxiliary electronic interfaces we find installed in some of our home-built aircraft. Then over on the side we have the GTX 45R. This is the remote mount version, as we mentioned earlier in the video. This gives us flexible mounting options in case we don't have space for this on the instrument panel. We can mount this someplace else in the aircraft, whether it is behind the instrument panel or in the back of the aircraft, and go ahead and interface through that with the G3X Touch system. This concludes our virtual overview of the G3X Touch electronic flight system. If you have any additional questions on what we covered today, please visit your local Garmin dealer or visit us at garmin.com.